Mario is going to work with a local carpenter during the summer. Each week she will earn $10 plus $2 per hour. Write a function f of x for Margot's total earnings if she works x hours in 1 week. All right, well, we know that she is going to earn $2 for each hour she works plus the 10, right? So I would write this as $2 for every hour, and she's going to get that 10 automatically. So let's now create a table here. If she works 0 hours for the week, she earns $10 regardless. If she works 1 hour for the week, she earns $2 in addition to the 10. 2 hours would be another $2. 3 hours, we would add another $2. 4 would be $18. 5 would be $20 because we would do 5 times 2 is 10, 10 plus 10 is 20. And 6 would give me 22. Let's go ahead and graph these. 0, 10. 1 hour is $12. 2 hours is 14. 3 is 16. 4 is 18. And 5 hours is 20. And we're going to go ahead and connect these with a line like so. All right, we're going to go on to question C for this set. It says, how much will Margot's earnings change if she works 6 hours instead of 2 hours? If she works 4 hours instead of 3? And how much do Margot's earnings change for each additional hour worked? Well, let's take a look at this. If she works 6 hours, we said at 6 hours she earns $22. So Margot will earn $22 minus, if she works 2 hours, she only earns 14. So that would be an $8 difference. So $8 more if she works 6 hours instead of 2 hours. Let's take a look at the next one. If she only worked 4 hours, she earns $18. So Margot will earn $18 minus 3 this time, which would be $16, which would be $2 more if she works 4 hours instead of 3. And lastly, it asks how much does she earn for each additional hour worked? She earns $2 more for each additional hour worked. Okay, let's take a look at D. Does the function have a constant rate of change? And if so, what is it? And that would be yes, and that number is 2. What is the slope of the line that you graphed? Well, we can use any of the ordered pairs that we came up with. I'm actually going to do the 622. I'm going to use this as my Y. Sorry, not my Y. I meant to say I'm going to use this as 0.2. Okay. We're going to call this 0.2. And I'm going to use this one as 0.1. I'm going to go back to that formula we used in the last lesson. And I'm going to do 22, which is my Y2, minus 16, which is my Y1. And I'm going to divide that by 6 minus 3, because that's my X2 and X1. 22 minus 16 is 6. 6 minus 3 is 3. And 6 divided by 3 is 2. So I got a slope of 2. Describe the meaning of the slope within the context of Margot's job. Where did that 2 already come into play? In the context of the problem, it's how much she earns for each additional hour worked, right? So the slope of the line, which is 2, tells us how much Margot earns per hour. Describe the relationship between the slope of the line, the rate of the change, and the equation of the line. The slope is the same as the coefficient of x in the equation of the line the slope is also equal to the rate of change. How much will Margot earn if she works 8 hours in 1 week? I'm going to go back to the equation that we talked about in part A. And that equation was 2x plus 10. So I'm going to do f of 8 equals 2 times 8 plus 10. 16 plus 10, she's going to earn $26. There's no debriefing for this section, but on to question number 3.